This week's lesson will be covering a few things about polynomials. We are going to look at addition and subtraction, and then a little bit on multiplication. First of all, what is a polynomial, you may ask? That would be a variety of different things. It could be a number, a variable, a product of numbers or variables, or quotient of variables. If there is only one term, then it is called a monomial. And if it is more than one term connected by additions and subtractions, then we call this a polynomial. A polynomial is a monomial, one term, or a combination of sums and or differences of monomials. So you only have additions or subtractions in a polynomial. In a monomial, the number that is in front is called the coefficient, and the letters that follow the coefficient are called the variables. In polynomials, addition is commutative and associative, so we can regroup things if we want to add them. So what we will do is we will regroup things so that they will be like terms put together, and these like terms are things that have the same variables raised to the same powers. Those are the only things that you can add, and the only thing that is different about them is that they have different coefficients. So for example, in the first problem, we have two polynomials. The first one has two terms, and the second one has two terms. If you look at the two polynomials, the two first terms, 3a squared and 5a squared, those are like, and the last two terms are also like. So what we will do is we will regroup them. So again, I've rewritten the answer. In red, you have the 3a squared and the 5a squared. Those two are like terms, so we'll put them together. Again, when we add like terms, we will only add the coefficients. It is like adding 3 of something and 5 of something, so we will get 8 of the a squareds. The other two terms are not like terms. Even though they both have a and b, they do not have the exact same coefficient, so you will not be able to add those. So the final answer to this is just the 3-term polynomial that you have at the bottom. When you have a polynomial, you try to write the powers so that they decrease from left to right. That is called descending order. So we'll try to write them in that order. If we want to subtract polynomials, we try to add their opposites. So again, to do a subtraction, we will find the opposite of the second polynomial. Two polynomials are opposites or additive inverses if their sum is 0, so they are negatives of each other. So for example, in the first one, if I have the polynomial negative 9x squared plus x minus 7, the opposite of that would be a positive 9x squared minus an x plus a 7. So each of the terms of the second polynomial is the opposite sign from the term in the first polynomial. Those are called opposites. Notice in the opposites, the terms are always the opposite in sign. So again, the negative 9 and the positive 9, the positive x and the negative 7 and the positive 7. We can find the equivalent polynomial for the opposite by replacing each term with its opposite. So we will change the sign of each term. So for example, in this one, if I wanted to find the opposite, I would indicate that by having a negative in front of the entire polynomial, as you can see. And then if I want to find the opposite, I will go through that entire polynomial and I will change each sign. So the first sign became positive, the second became negative, the third became negative, and etc., etc. So every sign of the polynomial that we started with becomes its opposite. So in subtracting, what we will do is we will change the middle sign, which is a subtraction sign, to addition, and then each of the signs of the second polynomial will become their opposite. So I have a negative sign in the middle becoming a plus, and then for the second polynomial, the first term will become positive, the 4a squared b will become negative, and the 6 will become negative. Once you do that, you will combine your like terms. So again, the like terms 5a to the 4th and 3a to the 4th become 8a to the 4th. And negative 7a to the 3rd does not have a like term, so it will come down. The 5a squared b minus the 4a squared b, those will be like terms, and you will subtract 5 minus 4, which is a 1. Notice you do not have to write the 1 in front. And then the minus 6 did not have 1 to add to it, so that will come down. If we go on to multiplying, we also may need to use commutative and associative laws. So in the first problem I have here, 4x times 5x, we will really be adding the 4 and multiplying, the 4 and the 5, and then the x and the x. So notice if you want to rearrange them, you will put the 4 following the 5, and then the x and the x together. Using the associative property, you multiply the two coefficients together, so 4 times 5 is 20, and then x times x is x squared. You do not have to show all those steps, but it's good to see what you are doing. So because you are using the commutative and associative laws, we are doing this with the proper method. Usually, as I said, the combined steps are not shown. You usually just multiply the coefficients and multiply the variables. So in the next problem, you will take the 5 times the 6 and the x times the x, and you will get 30x squared. In the second problem, you will have the 3 times the -1, which will be a -3, and then the variables x and y are not the same variable, so you can just write them as a product. So you use the product rule when you're multiplying. Now, if you have powers of the same base, the rule for multiplying powers of the same base is to keep the base and add the exponents. So in this case, we will add the 2 plus the 5, and that will make 7. The reason this works again is because x squared means there are 2 factors of x to the 5th means there are 5 factors of x, and that will give you a total of 7 factors of x. In the second problem, number 5, we will take the 2 coefficients, 5 times 3, and get a 15, and then the 8 to the 4th times the 8 to the 2nd will become an 8 to the 6th when we add the exponents. Similarly, in number 6, you will take the 2 coefficients, -4 times 3, and get a -12, and then add the powers of x. 2 plus 6 gives you 8, and then the powers of y. 3 plus 7 gives you 10. The last thing we will look at today is if we have to multiply a monomial by a polynomial. You will be using the distributive law, and to do that, you take the term that is outside the parentheses, and you distribute it or multiply it by each thing. So in this case, we will multiply the -3r squared s times the first term, and multiply the -3r squared s by the second term. So each one gets multiplied by the term on the outside, and you multiply them as monomials, which said we just multiply the coefficients together, and then for the like bases, add the exponents together. Hopefully this is a good review for you. Please review these sheets again, and if you have any questions, feel free to contact me.